afternoon. So we'll be talking today is the psychrometry of air conditioning process. So we have we have 8 processes now. So 1, we have sensible heating, and 2, we have sensible cooling, 3, we have humidifying, 4, we have dehumidifying. So for 5, we have heating and humidifying. So for 6, we have cooling and dehumidifying. And for 7, we have cooling and humidifying. And for 8, lastly, we have heating and humidifying. Okay. Or called sometimes or chemical dehumidifying. So we'll start to talk. We will be starting to tackle each of these process now. So let's start. So let's take with the 1. So sensible heating, no? So it is described as an air conditioning process that involves heating without changing the moisture content or the humidity ratio. The process can be represented as a horizontal line in the psychrometric chart. So we have the application, no? We have the application for adapting, like this one. So if we have your ducting here represented as a side view or the top view, no? Top view, so we have your point 1 here. So we have your air entering. Then we have your heater coil here, no? Then this shall be your point 2. Then you have your air leaving. Then you will be supplying here a medium or heated water. So let's say this is heated, or let's say not totally or heated water. Let's say it is a heated water in, then you have your heated water out, going out here. So usually our heater coil, so if you're going to dissect that one, so it will be look like this. So it's like coil running here, okay, where your air is passing towards it. So you will be having a heat transfer between the coil and the air. Okay. So that is the section. So if we're going to plot that one in a psychrometric chart, so we have here your dry bulb temperature going here, and you have your humidity going right here, then you have your curve. So usually starting from air entering, so maybe it is around, the temperature maybe is around 35 degrees Celsius, then it will be heated to a temperature, the air entering the coil, it will, let's approximate it is around 40 degrees Celsius, no? 40 degrees Celsius. So the process that will be, we have sample, we have 35 degrees Celsius dry bulb here, okay. Then running to 0.2, so this will be your 0.1 and this is your 0.2. So we have 40 degrees Celsius, and it is stated it is a constant humidity, so we have your humidity 2 and humidity 1 is unequal. So that is the representation. Then we have your heater capacity. So where Q is equal to the mass flow rate times the enthalpy 2, the enthalpy 1. So we can get also the value of enthalpy at this point, this line. So as you go to the intersection of the curve, you can point out what will be the enthalpy. So then we have your where your Q is the capacity of the heater. So this is the capacity of the heater. So that will be in kilowatts. Then we have your mass flow rate. So let's put it symbol here. So that will be is equal to volume flow rate divided by the specific volume 1. Okay. Then this will be your mass flow rate. So that will be in kilogram per second. Then so let's define it's Q1, volume flow rate of air entering the heater. This is the volume flow rate of air entering the heater. So that will be in cubic, the unit will be in cubic meter per second, so take note of that one. Then we have the specific volume. So this is the specific volume. Of air entering. So that will be in cubic meter, unit in kilogram. So we have also your enthalpy 1. Enthalpy of air entering the heater. So the unit will be kilojoule per kilogram of dry air. Then we have your enthalpy 2, enthalpy of air leaving the heater. So that will be the unit kilojoule per kilogram of dry air. For number 2, we have sensible cooling. Sensible cooling. So it's a process that involves cooling without changing the humidity ratio of the air. So the process is represented by our horizontal line and the psychrometric chart, so from right to left. So the final temperature cannot be below the initial dew point temperature. So we have also the application in a duct. So we have your cooling medium in, then we have your cooling medium out. So we have also here your coil. Okay. Then we have your air entering. Then your air leaving. So we have your heat transfer running here through the coil. So it is represented in a psychrometric chart by this straight line. So this time it is an opposite, starting from point 1 here, where we have your humidity 1 is equal to humidity 2. Then we have a straight line here. Okay. Then we have your dry bulb. This is point 2 now. So dry bulb 2, and we have your dry bulb 1. So it is a reverse compared to the sensible heating. So it is a reverse. Then we have your cooler coil capacity. So we have your Q, the mass flow rate, times your enthalpy enthalpy 1 minus the enthalpy 2. So this is represented in the units of kilowatts, or TR, which is the tons of refrigerants. So we have also the conversion of 1 TR, that will be 3.517 kilowatts. So take note of that one. Then number 3, we have humidifying process. Okay, so it's a process of increasing the humidity ratio without changing the dry bulb temperature of the air. So the process is represented in the chart by a vertical line upward. And the application is also the application is different from the previous, since we have your duct here. So we have your air entering here. So this will be a 0.1. Now we have to spray a mist of water here. So in such, this is in a particles. This such in a way that the mist will be absorbed by the air. So you have your water in here, and you have your air leaving here, which is have a higher humidity, or which have a higher moisture content. So in the psychrometric chart, it is represented by this line. So we try to make the dry bulb 1 and dry bulb 2 in equal or in constant, but the humidity is not constant. So there is a change in content since the air is absorbing a moisture from the mist of air, from the mist of water. So mist. So the mist will be the moisture content of air here. Let's say this is the RH of air here is maybe around 40%, and the air as it passes to this mist spray of, so this is a mist spray of water here. So this is also in constant temperature, no? So the air is absorbing a moisture content. So maybe around here is around maybe around 70% or 80% RH approximated. So it depends on the quantity of mist you will be providing to the spray of water. So this is how it looks like. Then we can compute the amount of moisture added, so that will be equal to mass of the vapor, that will be mass flow rate of air times the humidity 2, then humidity 1. So the unit is in kilograms of vapor, kilograms of vapor per second. That will be the units for that one. So let's proceed to the fourth one. So we have the humidifying process. So this time what we are doing now is removing them. So this time we're decreasing the humidity ratio of the air, so without changing the dry bulb temperature of the air. So the process is represented also in the psychrometric chart as the vertical line downward. So we have your application, this one using the air washer. So this is also the duct. Then we're providing a cooling, this time we're providing a cooling water here. So the cooling water, then we're going to spray it in the air washer. So the moisture content will be lessened as the air entering. So there is a big difference between the spray of the mist of water, because we're trying to absorb the mist, but this time we're trying to lower down the moisture content by spraying or by means of air washer. So you have a collector here below, then so you have your cooling water out. You have your air leaving here. So this cooling water is circulated back again to this part. Okay, then it is a cycle now. So this is represented in your psychrometric chart by a line from point 1 going to point 2. So you have your humidity 1 here, and you have your humidity 2, where your dry bulb 1 is equal to your dry bulb 2. So the amount of moisture removed, so the same also equation that what we use on the mass of the vapor, then the amount of moisture, as was I saying, is the same also. The amount of moisture removed is the same equation we will be using. So that will be humidity 1 minus humidity 2. So the unit will be also kilograms of vapor per kilogram of dry air. Next, we have heating and humidifying. So the process is simultaneous heating and humidifying of air by either drawing it through a spray or over the trace of hot or warm water. And the water must be heated during the process in order to supply a latent heat needed by the evaporation. So this time we'll be using a heated mist of water. So if we have your duct here, so the applications will be spraying a mist of hot water. So you have here your point 1 here, air entering. And you have your point 2 here, where it is leaving. Okay, so this is a mist, again, mist of spray heated water. So we'll see the difference. Now for the psychrometric chart, this one, so the process of this one will be look like this, since we have here your dry bulb now here, dry bulb 1 here, which may be, assuming it's 45 degrees or 30 degrees or 32 degrees, then it is heating, so we have a higher dry bulb here, maybe 40, 30, 45. So, and also we have a corresponding humidity 1 and you have humidity 2. Now it is heating going here, and also going towards here to increase the humidity. No? So this is how the psychrometric process it will be look like. Then we can compute also the amount of moisture added by means of the moisture vapor. It will be the mass flow rate times the humidity 2 minus humidity 1, and the amount of heat added is the same also equation that we are having. So that will be enthalpy, mass flow rate, times the enthalpy 2 minus the enthalpy 1. Next we have cooling and humidifying. So this is a process of simultaneously cooling and dehumidifying of air passing through a cooling coil or air washer. So the actual process is difficult to show in the chart, but it will depend on the type of equipment used. But in general, this can be indicated by a dotted line curve. So this process is commonly used in summer and for air conditioning, in which air passes over a cold coil through a cold water. The air is chilled below its dew point temperature and thus condensing the moisture, and the final RH generally is higher than the initial relative humidity. So we have your application for this one. So it can be represented by it can be done by means of an air washers. Okay, so that is, we're supplying here spray water. Okay, so this is we call this a cold. We're going to spray a cold water here. So this will be your cold water in, and we have your cold water out. So you have here your air entering at this point, and we have your air leaving at this point. So this will be your point 2. Or this can be also represented by means of using in a duct by means of a cooling coil. So we have your cooling coil here. Then we'll be supplying cold water in. Then you have here your cold water out. Okay. Then you have here your point 1, air entering. Then your point 2, air leaving. So in the psychrometric chart, this is represented. So I'm going to draw that one in the psychrometric chart. So we're starting here, humidity 1, okay, and with the corresponding dry bulb 1, no? Then we're trying to dehumidify. So okay, here. So you have here your point 2. So you have your dry bulb 2 here, or humidity 2. So you can be revisited is by another dropping here. Okay, so curve line you have, then condensing it. So in 3, then where the moisture condensed and the moisture was removed to the supplied air.